sorry, called NMTC, right? 2022. Okay, so you can see the problem.
Yeah, so there's a circle.
Right. Yeah, let me just draw the figure maybe. There is a circle. Is it okay to draw the figure directly? Yeah.
Yes.
Okay.
With O as center
Mm-hmm.
and OA and OB are two perpendicular radii drawn from there. OB is drawn vertically and OA is drawn horizontally.
Okay.
Now with A as center and OA as radius, there is an arc drawn which cuts the circle at C.
Right.
So it's drawn downwards.
Downwards. Okay. Uh, okay. So this is C.
Yes. And then BC cuts OA at D.
Okay.
So now they have told to find angle ADC.
Let me just. Yeah, my figure is not good. My circle is not. The original circle itself is not a circle. Which angle was it?
Angle ADC.
Where is D? Oh, D is there. Okay. Right. Okay. So this is the. Hmm. So do you know the angle?
No, sir, I tried this but couldn't find it.
Ah, okay, okay. Let's do this. See. Just change the figure because the figure is very misleading. I'm a little bad at drawing with this this pen tab thing. But let's just change it because it looks very wrong. This looks slightly better. Hmm. So have you made any observations? There will be many ways I can, several ways I can suppose. Do you have any observations?
Sir, I have tried to extend O at a point and then make two triangles to do something, but the angle is always getting cancelled out through
Ah,
the equations.
I see. Okay. Is D, C, let's call this E. Can you say anything about EC? Let's say OB is 1, right? That is fine. Unit circle. Unit circle. Because that doesn't matter. Both are with radius 1. Try to say something about EC if you can. So let me, if you forget the other things, can you now say anything about EC? These two circles are equal, right? And these are the centers.
OA is bisecting EC.
Yes. Why is it bisecting? I mean, I know it's kind of by symmetry because the two radius are equal, right?
Yes.
Yeah. And therefore, it is also perpendicular. But you should be rigorous about it. Okay, I'm just saying, but you have to make sure that it is correct from your arguments. Also, the perpendicularity check first if I'm correct. So we'll bring it in the original picture actually. So show, maybe it's not important. Yeah, but I will still call this X. So you have already told me that OX is half, right? OX equal to XA equal to half. And now I want, I mean, should be able to find out EX. And obviously EX and XC are also equal. So you can just find this and also see that EXA is perpendicular. But I'm not asking you to prove all this, but yeah, you see how you can use it. My plan is that if I know XA, right? If I know XC, my plan is that if I know XC and I know BD, then I can use similarity, right? Maybe to find out the ratio between OD and DX. You see, that's sort of my plan.
Yes.
Or there will be other ways also coming up. So yeah, so think about it.
Sir, it should be root 3 by 2 dx.
DX is or EX? Can you? I don't know. This headphone is not very loud. It somehow is max volume, but can you speak louder a little bit? Or
Yes, sir. Ex is root 3 by 2.
hmm, okay, then you figured it out. But how did you find it?
Sir, OE will be the radius and OX we know is half. So 1 square minus half square.
Right. So, but then you're using the fact that EX is perpendicular to OA. So you see that.
Yes.
Okay, then that's fine. Then it's root 3 by 2. Then you can just find everything, right? I mean, there is, this is simple, right? This is 1, this is root 3 by 2. This is also root 3 by 2. So you know that OD by DX also has the same ratio, right? Maybe 2 by root 3. But you know OX is half. Or you can find out everything, right? So can you find out OD maybe?
One by 2 plus root 3.
Right. So OD is 1 by 2 plus root 3. Is it correct? Yeah, should be correct. Yeah. But the problem is that from here, you may not know the angle. Uh, Does it tell you the angle? No. Uh, yeah. If we knew some means using some trigonometry, we can find, but otherwise, yeah, root 3 plus 2 by root 3, and this OD plus dx is half dx, and so dx is coming out to be, no, I am getting root 3 by 2 uh, times this. I'm getting slightly different. No, or is it something wrong in the calculations? No, it was correct, right? Yeah. So I'm getting a slightly different answer.
Sir, dx I also got the same thing.
Oh, sorry, that is dx. Yeah, okay. It's correct, sir. I'm sorry, just making a mess. This is OD. Sorry. So this is OD. So I don't know what OD is. It's not very clear. So maybe we can try to rationalize it and see. 4 minus 3 is 2 minus root 3. 2 minus root 3, I don't know. Yeah, and even with trigonometry, you have to know what 2 minus root 3 is. Are we doing some calculation mistakes or?
Tan of angle BTO will be the angle we're looking for only, right?
Yes, that's right. So we need to find the theta for which it is equal to this. Now, this is, I mean, if it's a standard angle, then it is something that one should know, but obviously I have sort of forgotten the tan. But you can just, this is something that you can just look it up. But let me see. So if it's 2 minus root 3,
Sir, it's plus, I think.
no, so I've reversed it, right? Rationalized it. Just check.
Sir, but we have to do BO by OD, right? 1 by 2 minus root 3.
Oh, check. Yeah, I'm making too many mistakes today. Yeah. So we have to do BO by OD. That's the standard thing. Yeah. Yeah. Anyways, so all of this comes down to this theta. So tan theta is equal to 2 plus root 3. I mean, if it is anything, it should be maybe 75 or something, right? Tan 75. I mean, I can obviously calculate it and check, but let me just check it on the internet. It will be faster. Wait, what? No, degrees. I mean, if you know the tan formula, you can just calculate it. No, so there are tan 15 degrees and so on. 3 plus. Yeah, that's what it is. Yes. So this is, the internet tells me that it is 3 plus 7.3. And you see, this is like 2 plus 1.73, right? So this is correct.
Yes.
But let me say maybe nicer way. See, the point is, you maybe, do you know this? Do you know how to calculate tan 75 degrees?
Sir, it's cot of 90 minus 75, right?
Sorry?
It will be cot of 15 degree.
That is fine, but how do you calculate? Do you know how to calculate cot of 15? Or anything of 15 degrees, sine 15, anything is fine. You can get tan from there.
So I don't remember just sine 15.
Yeah, but do you know how to calculate it even if you don't remember? Find it. I'm not.
No.
That's because that is the important thing, because remembering is not the important thing here. But okay, so that's fine. This we can discuss at some later time. Means how to, or maybe we can just discuss it now. So, but you do know, if you have to make a guess, right? Then there is a thing. You know that tan 60 degrees is root 3.
Yes.
This you know. And so if it is bigger than root 3, so they see the most natural choice is 75 degrees.
Yes.
There's no other, because you cannot find tan 80 degrees, right? In sense, you understand, right? Yeah, 80 to 10 degrees is sort of 30, 15, 7.5. Those are good. So based on that thing, I said that it should be 2 plus root 3. Okay. So from here, we have two directions. Okay. One thing is to do this problem directly using angles, because that should be more natural, right? But obviously, it may not be the easiest way. Okay. So one is using only angles. So we are using trigonometry, which is good, right? Because you take any right angle triangle, as long as the theta is fixed, they are all similar. And so the ratio, you can always, from the ratio, you can tell the angle. That's the beauty, right? And so we are able to do that. But directly using angles, that's one thing. And the second thing is to try to learn some basic trigonometric calculations, right? So that in an exam, you will not just be able to guess, but also be able to tell that this is tan 75 for sure. These are two directions. So what
So here did we assume that EC is perpendicular to OA?
BC is BC?
No, EC is perpendicular to OA. Did we assume this?
No, you showed it, no? It's in the middle. I asked, right? Is it clear? I don't know. Maybe. Yeah, it is perpendicular, right?
Sir, I can see it through the symmetry, but I don't know the proof.
Right. Okay, no problem. So here, it is, you see, it's an isosceles triangle, and this is a bisector. So from there you can see.
Yes.
Yeah, but in a way, this should also be actually very important to explore, because, so let me give you a problem which you should try for homework, and surely do try this. That if you have any circle, maybe a big circle and then you have a small, and don't worry, I mean, you're just starting to do circle geometry. So if you did not able to do this problem, it's not a very big deal. Okay. If you have to, and you can just draw and you can tell yourself that this is true. But then try to prove this, that if you join the centers, even so it is, my point is that it is not due to the symmetry only. Okay. It's something more than that, that causes this line to always be perpendicular. It is obviously true. You can see it in the picture. It's not false.
Yes.
But it's a very interesting result in some way. And it's very, very useful. Try to do this for homework. Okay. Okay, so this is your homework. And I will discuss this. And the last is some problems are also there. I will discuss all of them. So this is fine. Now there are these two. But my first priority would be if you have some other more problems from the exam which you want me to discuss, then I'll discuss them first. And we can do this sometime later. These two routes we can take later. Yeah. So you have any other question on the exam? I think that we should do because you just gave the exam yesterday.
Just a minute, sir.
Yes.
Yes, sir, there's another problem.
Mm-hmm.
If a plus b is equal to 2,
So A and B are just
and
numbers.
here they are any real numbers,
Okay.
and 4 raised to a plus 4 raised to b is equal to 6,
Mm-hmm.
then the numerical value of 2 raised to 2 into 2a minus 1
2 raised to 2 into 2a minus 1.
yes, plus 2 raised to 2 into 2b minus 1.
Mm-hmm.
This
This
we have to
is
find.
the question.
Yes.
So what have you tried?
Sir, I had tried to put it in the power of 2. So 2 raised to 2a plus 2 raised to 2b is 6.
Mm-hmm.
And then if we take 2 raised to 2a common, then 1 plus 2 raised to 2b minus 2a will be 6.
1 plus 2 raised to a minus
2b,
b minus a. Right.
yes, b minus a. Now this is 2 into 3.
Why is this 2 into 3?
Because 6 is 2 into 3.
Okay, 6 is 2 into 3, so what? That doesn't mean that this has to be 2 into 3. Anyways, let's see. I mean, if 2 raised to 2a is 2 and this is 3, okay, then
Then I had found the values for a and b, but when I put it in the equations, they were not matching.
they don't match any of the options. Are there options?
No. Yes, there are options, but it's not matching.
Is not matching. Yeah, and the reason is why should this imply that this is the situation? Because that's why these are real numbers, right? 6 is not 2 into 3 only. 6 is many other things. Okay. For For example, root 7 minus 1 times root 7 plus 1. Yeah, I understand that it's naturally that, but yeah, we don't know. So this is how else can we try this question? Do you think of converting this into quadratic or something? Quadratic equation. Like, what if I write, let's say I say, sorry, it would be the same thing. Yeah, let us just say that 4 raised to a is equal to x, right? Then the other thing is 2 minus a, right? And then what is this? This is 16 by x, right? This is 4 raised to b, right? And then you see, so using the first equation, right? A plus b. So I'm trying to bring everything down into one variable and not with exponents, right? Because basically everything down with one variable. Then you have this. You can surely figure out x from here, right? Let's do it. Um, oh, it's not a real number. No, something is wrong. Are you sure that this is? Are you sure that this is 6 only? Oh yeah, it is. And I wrote, no, I wrote correctly only. If 4 is to, just tell me if I'm doing some calculation mistakes.
No, sir, it's correct.
Seems correct, yeah. And but this implies that x is not real. But if a is real, then x has to be real, right?
Yes.
Something is wrong with the question. I mean, as much as I understand, I'm not claiming anything, like, but logically everything seems to be correct.
So for this, one solution can be A is 1 and B is half.
Yeah, no, but that doesn't satisfy the first one, right?
Yes. The question could be given wrong.
The question?
Could be given wrong.
Yes, right. I mean, so yeah, it's clearly, and also you could give other types of explanations also, but yeah, let's not. I mean, what I'm just saying is that you can apply that A and GM inequality, right? And that also gives you that it is at least 8. Right? It is at least 8, right? You don't even need to convert it in anything like that, right? You can just say that 4 to the A plus 4 to the B is at least 2 times 2 to the A plus B. You can just apply AMGM, take the square root. I've done all that and I'm saying like this, right? There's at least 8. So even just to begin with, the question is wrong. It cannot be, it could be 16, but no, but I'm not going to guess all that. Okay. And maybe that's why your thing about 2 into 3 also did not work. Otherwise, I was thinking for a second that such things do work in exams, and it looks like nice and so on. Anyways, yeah. So yeah, question seems incorrect. So how was the exam in general? How did you feel? I mean, in any.
So this was the first time I'd appeared for it,
Mm-hmm.
and I hadn't practiced much, but I think I got some of them correct. I don't know.
Okay. So how many questions are there?
Total there are 30.
30. Okay. Yeah, I don't know, but this is like the first time you wrote any serious math exam. Is that way to
No,
put it?
this is just the first time I wrote NMTC.
Oh, okay, okay. Okay, okay. No problem. No, but earlier, have you written any like PRMO?
No, sir, but I'd appeared for, I think, IMO, the SF1,
Yeah,
and
but
IPM.
SOF thing that's nothing compared to NMTC or
Yes.
RMO. That is not serious. IPO maybe, yeah. No, but that is also like SOF. Yeah, no, those are, yeah, compared to these exams, those are. Yeah. Okay, no problem. Yeah. So which area do you think you're lacking? Maybe that is like what would have helped you score more? Maybe which topic do you think?
Sir, I think I have to improve in geometry.
Geometry, yeah, because we also did less geometry, and maybe you also, yeah, and also the kind of geometry we did areas and all long time back, not much of this circle geometry and so on. Okay, so let's meet on the other side and discuss more, and then we'll see. Okay.